In previous class, we started discussing about the three-phase circuits. So as we already discussed, the three-phase, it may be connected in either star or it may be connected in delta. So right now, so we are looking into the star connection. In case of star connection, the phase currents and line currents both are same, but the phase voltage is 1 by root 3 times line voltage, 1 by root 3 times line voltage, and moreover the phase the line voltages are advanced by 30 degrees. Okay, so come to the power. So we have three phases here, right? So we have three phases here. So the power is power in each phase, right? The power in each phase. So how to calculate the power in each phase? In case of active power, so power in each phase, right? So that is 3 times, okay, 3 times V phase, I phase, cos theta. So this is the phase voltage RMS value. So this is phase voltage RMS, phase current RMS value. So this is also equal to I line. Agree? So this cos theta is angle difference between, right? Angle difference between voltage phasor to current phasor. This is for R phase and this is for R phase. Right. In case of balanced thing, so this phase difference is common, right? So this is also equal to voltage difference between Vy and Iy, Vb, Ib. In other words, Vbn, Rn. So this is the angle difference between phase voltage to phase current of respective phase or same phase.
Is this some sort of notation or some kind of representation, sir?
Which one? This one.
Yes, sir. Is it some kind of
This
representation?
is the meaning of theta. So this theta, so how you will represent it? Theta is the angle difference between voltage vector to current vector of the same phase.
Okay, sir.
Yes?
The power is V line into I line into cos phi, right?
No, we have three phases, right? So this is the power. So you have one phase, second phase, and third phase, right? So this is three-phase power. So how exactly we'll represent it V line terms is, so V phase is root 3 times, okay? V phase is root 3 times line voltage, right? So this can be written as root 3 times V line, agree, into I line. So both are same. So this is cos theta. Agree?
Yes, sir.
Okay. So this theta is still this one only. Theta is the angle difference between the voltage phasor to line phase voltage phasor to phase current phasor.
Sir,
Understood,
yes?
sir.
sir, that root 3 I line, no, sir? Only I line,
Yes,
why?
sir.
Root 3 V line into root 3 I line, no, sir?
Yeah.
But you have written only root 3, no, sir? It should become 3, no, sir?
Why 3? So this root 3 into V phase is V line, right? So root 3 into V phase. So this is
sir, V
equal
line.
to V line.
Root 3 into I phase also I line, no, sir?
Why root 3? The currents are same, no? So in case of star connection, phase current and line current both are same.
Okay, sir. So then
Wait,
P
it's a
line
root
is
3
root
count.
3 into P of phase, sir.
Yes, what you're saying?
Power in the line for the line voltage is root 3 into power of the phase voltage, sir. We got 3, no, sir. There, root 3 into root 3 means 3, no, sir. One root 3 is root 3 VPH. Another root 3, where did we get, sir?
So this is the one.
Sir?
So we have this, see here, we have this 3 power is 3 into V phase, I phase, cos theta, right? Okay, agree?
Yes, sir.
Okay, this I have written as root 3 into root 3, V phase, I phase into cos theta. So this root 3 into I phase is root 3 V line. So
Yes,
this
sir.
phase and line both are same. So this I line cos theta.
Okay, sir.
Okay. So you need to understand these basic things. Okay, I cannot every time I cannot split these things into a head. You have to use your
No,
brain
sir.
at least. Okay.
Sir, we were asking in this root 3, where did it come from? The bottom line, root 3 into V line, I line cos, right?
This one.
No, not that, sir.
This one.
Like, no, yeah, that one, sir, that root
So
3
this
in
is the
that
one
line.
here, right?
So in a three-phase like star connection, power is 3 into V phase, I phase, cos theta.
Okay. So this
Is
3
that
is written as root 3 into root 3. Okay.
okay, sir? Got it.
So this root 3 is this one only, right? You need to think at least. So this is a simple thing, and yet you are confusing. See here, just a simple thing, right? So this can be written as, we have the relationship is root 3 into V phase is V line. So if you want to express in terms of line voltages, this is the one. Agree?
Yes, sir.
Okay. So next but the angle is still the same. Okay. So this angle is VRN to IR. So don't confuse with that. So don't think that, so this theta is the angle difference between V line and I line. So that is wrong. Similarly, we have this reactive power Q. So that is 3 into V phase, I phase, sine theta. So this theta is same here. So this can be written as root 3 V line, I line, sine theta. Okay. Similarly, apparent power S. So apparent power is 3 times V phase, I phase, right? Or in other words, root 3 times V line, I line. Agree? Any doubts here?
No,
Any
sir.
questions? Okay, right. So this is the power in 3 phase. So why exactly 3 is coming? So single phase power is V phase into I phase, right? We had 3 phases. So that's why this 3 term is appeared here.
Understood, sir.
Right? So next we'll try to solve one problem. Three equal star connected inductors take 8 kilowatt 8 kilowatt at power factor of 0.8 lagging. Lagging when connected to a goes 60 volts 3 phase, right, star connected supply. Right. Find the circuit impedance per phase. Find the circuit impedance per phase. So what is given here, right? So three-phase star connected inductors will take 8 kilowatts, right? The thing is that inductor will not take energy, right? Or will not consume any energy. So that means, so these are the practical inductors. So that means inductors is having some resistance also. This inductors is having some resistance also. And these are operating at 0.8 power factor lagging. So here, so this is P is given, right? So P is equal to 8 kilowatt. So P is 8 kilowatt. So another thing is, so this 460 volts. So this is nothing is mentioned here means, so this is the line voltage RMS value. In case of three-phase system, right, if nothing is mentioned means, we already discussed this, so it is known as line voltage RMS value. In case of single phase system, if nothing is mentioned, so that is phase voltage RMS value. So this is 8 kilowatt. So this is equal to root 3 times V line I line cos theta. So root 3. So what is V line here? It's 460. So I line, we need to find out cos theta is 0.8. So this is equal to 8000. So what is I line? What is I line?
21.7.
What is its value?
12.5.
12.55 amperes. Okay. So this is I line in this is star connected system, right? So this is also equal to I phase. This is also equal to I phase. The question is impedance per phase. So Z phase. So what is Z phase? V phase divided by I phase. Agree? Agree. So Z phase is V phase by I phase. So what is V phase here? So line voltage is 460. So V phase is 460 by root 3. So that is V phase. Agree? And this is I phase. So I phase value is 12.55. So how much this one? So what is this value?
21 point.
So why are we
21
taking the
point?
RMS value, sir, for
Hmm?
V phase? So why are we taking the RMS value?
Why?
Why V phase we are taking as RMS value 460 by root 3?
So this is phase voltage, right? Line voltage
Yes,
is
sir.
given. So phase voltage is 460 by root 3.
Yeah, sir, got it, got it.
Okay. We're not dividing with root 2. That is root 3. Because of the phase to line voltage relation in star connected system. So how much it is? 21 point? 21.1 ohm,
Sir,
right?
21.15, sir.
Okay. So this is Z phase is given and you know the power factor. So how to decompose this into R phase? What is R phase? What is R phase? We have this triangle, right? You remember. So this R, so this X, and this is Z. Okay.
First cos theta.
So cos phi is equal to r phase by z. Cos theta is equal to r phi by z.
R phase is how much it is? Z phase into cos theta.
Theta.
Agree? Similarly, X phase is Z phase into sine theta. So what is this value? Z phase into cos theta?
16.36.
16.36.
36. Yes, sir.
Okay. Ohm. And Z phase is, X phase is
Sir, 12.06, sir.
12.06.
06.
Okay. So that means what is the impedance? Z phase is, so 16.36 plus sign or minus sign. So this is inductance, right? So the plus
Inductance is
sign
positive,
here.
sir, plus.
Plus
So
sign.
this is J 12.06 ohm.
Yes, sir.
So this is the impedance of the circuit. So next, try to do this. So this is ZL. So this ZL is how much it is? 8 plus J6 ohm. Okay. So this is 400 volts. Okay, this is 400 volts. So now you need to calculate. So this is supply is 400 volts, star connected. 400 volts, star connected. Calculate active power, reactive power, and apparent power. Calculate active, reactive, and apparent power. So what is the active power P? Right, what is the active power P?
Sir, 2176 watts, sir.
2000?
176 watt.
No, it's wrong. What is active power free? So 3 into V phase, I phase, cos theta, right? So
Sir,
what
it's
is
given
3
V line,
into?
no, sir. 400 is V line, no, sir.
Now we can convert this, no? 400 by root 3. We can do with line voltages also. What is I phase? How to calculate I phase?
400 by root
400 by root
8
3,
plus J6.
right? Square root of what is impedance here? 8 square plus
10, sir, 10.
6 square, right? So how much this is? How much it is?
40 by root 3.
40 by root 3. 40 by root 3 is 23.1. Is this correct?
Yes, sir.
Okay.
So directly we can write a V phase square upon Z into cos theta. V line square upon Z into cos theta, power.
What?
Direct substitution of.
No,
So
we can
direct
do that.
substitution of I phase, it will calculation will be simpler.
What you are saying?
400 upon sir, if we substitute 400 upon root 3, calculation will be simpler, sir.
400 upon root 3?
Root 3. Directly we substitute in I phase, calculation will be simpler, sir.
I didn't get to what you are saying.
Sir,
What is 400 by root 3?
sir, 400 is
Nothing, sir. Please continue.
It's correct only, right?
Yes, sir.
Someone is saying 400 by root 3, it will be simplified or something like that. He's saying. What is that?
For manual calculation, it will be simple, sir.
That's okay. It's up to you, no? Okay.
Yes, sir. Yes,
So
sir.
how exactly it is there, I'm writing here. Okay. So this is what is cos theta? What is cos theta?
0.8, sir.
So cos theta is
0.8.
that you know this R and X values, right? So that will be 8 by, in other words, R by Z, right? What is R? R is 8. So Z is, what is Z? 10, right? So that is 0.8 lagging here. So it is into 0.8. So how much this one?
So 12.8 kilowatt.
12.8 kilowatt. Similarly, calculate P and calculate S.
The Q is 9.6 kilowatt.
Q is
9.6 kilowatt.
9.6 kilowatt. Kilowatt, no, it is kVAR.
Oh, sorry, yes.
So
kVAR.
what is S? 12.8, 9.8, I think 16. Is it correct?
1600, sir.
Yes,
16,
sir.
right? 16
16 kilowatts.
kVA.
Kilo VAR.
Kilowatt, yes, sir. Kilowatt amp.
16 kVA, right?
Sir,
Yes.
sir, 400 volt is line voltage, no, sir?
What you are trying to say?
Sir, 400 volt, I have taken P is equal to root 3 into V line, I line, cos theta, sir, for P.
Yeah.
400 volt is V line, no, sir?
V line only.
Sir, if I am trying to calculate I line and I phase, sir, both are same, you told, no, sir? I phase and I line as both are same.
Yeah, both are same only, no?
Then can I write I line as a V line divided by impedance?
I line is what you're saying?
V line divided by impedance, sir.
V line divided by impedance.
Impedance.
That is not the relation, right? Okay. This is
We have
not
to take V phase only, sir. There I line.
Hmm.
For I line, for calculation of I line, we have to take V phase upon impedance, no, sir.
See here, this impedance, right? So this is acting only on the phases, right? It's the fair phase impedance.
Sir,
Yes.
sir, how to calculate for different cases of I line and I line in the previous problem we have taken I line is equal to V line divided by impedance, no, sir.
Where?
Yes, sir.
This one.
Oh, V
V
phase
phase by I
Z.
phase only, right? This is already
Okay,
we
sir.
said cut, right? So this Z phase is V phase by I phase. So when you're deriving
Okay.
these equations, right? So this cos theta is for phases only. Okay.
Okay, sir.
So here remember that this is the first formula. This is the primary one. Okay. So from this only it is derived.
Okay, sir.
So from this only it is derived. Because it is having the relation between cos and sine. So that's why in the when I say that this cos theta is, this is not the angle between V line and I line. So this is wrong. Okay. It must be the angle between the V phase and I phase.
Okay, sir.
It's clear, right? So next we have,
Sir, small doubt.
yes.
I phase is there, no, sir. In that impedance, only the impedance of one inductor only we have given.
This is phase only, right? For each phase you have one inductor only.
Okay, sir. Yeah, understood.
So next we have delta connected loads or the delta connected supply. Delta three phase supply. Delta connected three phase supply.
Sir, I have a doubt.
Yes.
Sir, in the star connection, every time the magnitude of V phase always be the same for all the three phase.
Yeah, we already discussed that what is one is the balanced supply and unbalanced supply. So in case of balanced supply, all the magnitudes are same. V phase, R phase, Y phase, B phase, all are same.
Okay.
Okay. In case of unbalanced, it will be some deviation will be there that we will discuss in the later classes. So right now we are dealing with balanced supply and balanced loads. So load is balanced and the supply is also balanced.
Yes, sir.
Okay. So let us assume that, so this is VR N, okay, right? So there is no neutral here, so there is VR, so this is VY, and this is VB, okay? So this is IR, and this is IY, and this is IB. Okay. Agree? So it is connected like this, right? Sometimes, so here this we are represented with voltage source, right? So this is actually a generator. So sometimes what we, instead of this voltage sources, three-phase supply, sometimes they're represented as a inductors. So this is one way to represent the three-phase source, right? So this is not exactly the inductors. So this is the winding of, right? So winding of the generator. So this is the winding of the generator. Instead of representing with voltage sources, so they will represent like this also. So this is also same, both are identical. Similarly for star connected system, so they will represent like this. So this is the representation of a three-phase generator. So this is not the inductance. So this is the winding diagram. So the winding representation. Here three windings are there. So which are displaced by 120 degrees, something like this. So it's something
How do you
like
say the difference, sir? How do you say the difference? If it's how can we say if they are actually like mentioning the inductor or a winding?
So that's why I told you, right? This is one circuit here, and the other side you have circuit something like this. Okay. It will be like this. Okay. So there will be in the next to this, they will write something like that 415 volts, three phase, star connected. So that means, so this is the source. Okay. So your question is valid. So how to differentiate that, whether it is a source or load? That is your question, right? Okay. So in case of that, they will mention like this. This is 415 volts, three phase, star connected source. On the other side, you have generator. Understood? So instead of showing this as voltage source, so sometimes they will represent, or sometimes they will show the windings, that is windings of the generator. Okay. Right. So now, so in this case, the delta case, so there is no neutral, right? So there is no neutral. So there is no common point, right? Like star connected system, right? So this will be the neutral. So in this case, so there is no neutral, right? So there is no neutral here. Okay. So now we will differentiate. So what is line current and what is phase current? What is line current and what is phase current? So let us connect a load here, right? So load may be, assume that load is also delta connected load. So this is the load. It will be connected like this. Okay. Say this load is ZL, for example. Right. So now tell me what is phase voltage here. So this VR, So voltage across this winding, so that is the phase voltage, right? So this is phase voltage and this is the phase voltage. Agree? So now what is line voltage? So this is inside the machine, right? So all these things are inside the machine. Okay. So what is outside here? What is this voltage? So what is this voltage?
9 volts.
So this is line
V
voltage.
R Y. V
This is
R.
line voltage. So now tell me, so this voltage, right? So this voltage and this voltage, so both are
Same,
same, right? Agree?
Yes, sir. Same.
Both are same, sir.
What you understood that in case of delta connection, line voltages and phase voltage both are same. Agree?
Yes,
In
sir.
case of delta connection, line voltage and phase voltage both are same. So this is, for example, this R, so this will be Y and this will be B. So this voltage is VRY. Okay, so that means VR equal to VRY. Similarly, so this voltage is VYB, and similarly this voltage, so this is VBR. So these phase voltage and line voltages both are same. In case of star connected system, so there is a factor of √3 present, but in case of delta connected systems, so both line voltage and phase voltage both are same. Clear? So whatever this is appearing, so this is also appearing across the load. The same thing, so that is also appearing across the load. So in this case, V phase equal to V line. In other words, I line or we'll come back to that. Okay. So this is the relation. So now this IR is, so this is the phase voltage, phase current, right? And this one is the outside of this machine. So that is the line current. So what exactly this current is? What exactly this current
IR
is?
plus
IR
IR minus ID.
IR minus IB, right? Agree?
Yes,
So
sir.
what is this one? So what is this one?
IY minus
IY minus
IY
IR.
minus
R.
IR, right? And what is this one?
IB minus IY
IB
IB
minus IY.
IY, right? Agree? Similarly, this current is, same current is flowing here also, right? The same current is flowing, so here also. So this is also IR minus IB, agree? So again, this current is split into two parts. Again, so this current is split into two parts. So this is the phase current of the load, and this is the phase current of the load, and this is the phase current of the, or this is the line current of the load, right? Agree? So this is the line current of the load, and these two are the phase currents of the load. So what you understand that the line current and phase current, so both are different. Agree? Line current and phase current both are different, right? Agree?
Yes, sir.
In other words, line current is the difference of two phase currents. Line current is the difference of two phase currents. Okay. So usually, so it is IY minus IB, right? If you take it in other direction, for example, I think, okay, I don't want to confuse you. So now draw the phasor diagram. Right. So phase voltages are same. So draw the phasor diagram for the phase currents. So assume that the current is, so this is,
Draw the phasor diagram for
currents, phase currents. We are finding out the relation between?
Sir,
Yes.
sir, the loads must be equal, sir, for balanced circuits.
Loads are equal, no? We
Yes,
already discussed that balanced source and balanced load.
yes, sir.
Okay, balanced source means magnitude and say balanced load means, so whatever this ZL, ZL all are equal, so then it is a balanced load. In case of unbalanced load means, so this is one thing and this is another thing, so that is known as unbalanced. Right. Okay. Right. So we have this relationship, right? I line, in other words, I will denote with. So here, so remember this, it should be IR minus IY minus II. So that depending on the direction if we consider, right? That depending on the direction we consider. So usually we have I, RY, I, YB, and I, BR. So what is IRY? So it sheets IR minus
IR
IY.
minus IY, sir.
So this is IY minus IB, and this is IB minus IR. So don't be confused here, right? So don't be confused with, so why you may doubt that why it is IY minus IY. So depending on the direction you consider, right? So if you assume that, so this is plus here and this is plus here. Okay, so that means, so this is IY, okay, and this will be IB. In other words, this will be this is IR, and this will be IY, and this current is now IR minus IY. Okay, so directions are not material for us. So only thing is, so what is IRY is IR minus IY. Okay, in case of IYR is IY minus IR. So that is the thing. So let us assume that this is IR vector, and this is IY, and this is IB. So what you are trying to do is IR minus IY, right? So IR minus IY. So draw a line. So this is minus IY. Agree? So this is minus IY. And we are trying to subtract with this. So this will be the resultant IRY. So what is the angle it is making here? What is this angle?
30 degrees, sir.
30 degrees, right?
30 degrees, sir.
So now tell me what is IRY?
Root 3 IR, sir.
So it is 2 times. So if you divide this into half of this one, right? So from here to here, so 2 times. So what is this magnitude? So what is that magnitude is IR into cos. How much angle it is?
30 degrees.
30 degrees, right? So 2 times IR into cos 30 is root 3 by 2. So you left with root 3 into IR. In other words, IR, IY, and IB equal to I phase. So in that case, right? So in that case, so what you are getting is IRY, in other words, I line equal to root 3 times I phase. Root 3 times I phase. So here also, so this angle is, it is heading by 30 degrees. And it is leading by, leading IR vector by 30 degrees. It is heading by 30 degrees. So everything is same. The only difference is the current where we have current, whatever those are valid for current. So here, so those are valid for current here. So voltage here. In case of star connected system, so voltage is root 3 times the phase line voltage is root 3 times the phase voltage, and it is heading by 30 degrees. But in case of delta connected systems, voltages are same, but the currents are line currents are root 3 times the phase currents, and which are 30 degrees ahead by the phase voltage. Okay, so you can also represent so with this by using the phasor diagram. For one example, I consider.
Also previous slides are on.
Yeah.
Okay, sir. Okay, sir.
So now tell me, is there any difference in powers? P, what is P here? What is P here? So we have three phases, right? 3 times V phase into I phase cos theta, right? Agree? So there is no change here, right? V phase,
sir.
I phase, cos theta. Right. So now you
Yes, sir.
have know that. So V phase and I phase, V phase and V line. So both are same, right? So this will be root 3 V line into, so this is I line cos theta. Agree? Agree?
Sir, then both the star and delta power is same, no, sir?
Yeah, power is same. So Q is again root 3 V line I line sin theta, and the apparent power S is root 3 V line I line, or in other words 3 times V phase I phase. Again this angle is same phases, this angle, whatever this angle is there, right? So phase voltage to phase current angle. So this theta is always V phase to V line, sorry, I phase. Okay, so this angle is V phase to I phase angle. That is the angle difference between voltage phasor to current phasor of the same phase. It should be of the same phase. It should not be R phase, and it should not be B phase. It should be of, so both should be of same phase only. Clear? You have any questions? So note down one problem.
Previous slides are on, sir.
Just a minute.
We don't have a neutral connection in delta, sir.
No. So you have no connection here, right? So this belongs to R phase, and this belongs to B phase, and this belongs to R phase, Y phase, B phase. So no neutral means which is not common to all, right? So we have only 3 terminals. Okay. So there is no neutral here. So let us assume that this is ZL, and this is also ZL. So ZL is given as 5 at an angle of 45 degrees. 5 at an angle 45 degrees. So what is your doubt? Someone has asked something. What is that? That is about the neutral in star connection, delta connection. So assume that, so V phase is given 120 volts. V phase is given 120 volts. Calculate, right? So calculate. So there assume this is IAB, right? IAB, and this is IBC, and this is ICA. This is A phase, B phase, and C phase. Calculate IAB, IBC, and ICA. Calculate IAB, IBC, ICA phasors.
So now can you go to the previous slide, sir? Yes, sir. Thank you.
Also calculate IA, IB, and IC. So it's denoted with IA, IB, and IC.
Sir, 24, 8 row 3, sir.
We'll solve this. Right. So phase voltage is given, right? In case of delta connected system, right? Assume that this is delta connected system. So both phase voltage and line voltage both are same, right? So that means V phase is also equal to V line. So this is equal to 120 degrees. So that means we have 120 degrees at an angle 0, 120 degrees at an angle minus 120 degrees, 120 degrees at an angle minus 240 degrees. So these are the phase voltages or line voltages, right? Agree? So this will be VAB, VBC, and this is VCA. Agree? So now what is IAB in this particular circuit? What is IAB?
Sir, 24 at an angle minus 45 degrees.
What is IAB?
24 at an angle
This
minus
is
45 degrees.
so this is IAB, right? So this one. So what is the voltage appearing across that particular these 2 points? So that is
120.
voltage between A and B, right? So that is 120 at an angle 0 divided by what is that impedance? 5 at an angle 45 degrees. So how much it is?
24 at an angle
24 at an angle minus
minus
45
45
degrees.
degree.
Agree? So what is IBC? It is 120 at an angle minus 120 degrees by
165, sir.
65.
Minus 165, sir.
24 at an angle minus 165 degrees. What is ICA?
My 24 at an angle minus 285 degrees.
24 at an angle minus
285.
285 degrees. All these are amperes. Okay. So this question are also asking for IA, right? So what is IA here? You apply KVL. What is IA here? If you apply KCL at this node, what is IA? So what are the incoming currents? IA can be, so it may be
ICA plus IAB, sir.
Yes, sir.
IAB minus
IAB
ICS.
minus ICA. Is this
ICA.
correct?
Yes, sir.
IAB minus ICA, right?
Yes.
How much it is IAB minus ICA?
Plus IBC also divide by 2.
Why divide by 2?
Sir, only I in that way IB and IC will be there.
Hmm? So this node, right?
IC minus IB.
Okay, sir.
So IA is the incoming currents, ICA is the two are the incoming currents. So only IAB is the outgoing current, right? So IAB plus IA plus ICA equal to IAB. So from that, IA is IAB minus IC. Is this correct? Any questions here?
Correct, correct.
Okay. So what is IAB minus ICA? IAB minus ICA. That means 20 at an angle minus 45 minus 24 at an 24 at an angle minus 45 minus 24 at an angle minus 285. What is the answer?
$41.5 at an angle minus 70.
41.5 at an angle
Minus 75 degrees.
minus
75.
75 degrees. Hmm?
Yes, sir.
Okay. So you have one side you have 24, right? And another side you have 41.5. So if you multiply 24 into 24 with root 3, so how much you will get? So this will be 24 into root 3 at an angle minus 75, right? So this angle difference is also 30 degrees. This angle difference is also 30 degrees. Similarly, what is IB and IC? What is IB and IC? What is IB? So this magnitude is same, but it is again shifted by minus 120 degrees, right? So that means minus 75 minus 120. So this IB is 24 by root. If this is this correct? This one. That angle is correct? Hmm? So it will be minus 75 minus 120 degrees.
Excuse me, sir.
Yes?
Sir, IA is the phase current, no sir?
Line current in this, see the diagram here. This is the line current here. So IAB, ICA, IBC are the phase currents.
Sir, how you got the minus 75 degrees, sir, in IA?
Someone has told, no, that minus 75. So this is difference between 24 at an angle minus 45 minus 24 at an angle minus 285. That is
No, sir.
the answer, right?
Line current will lead by 30 degrees, no sir?
Yeah, that we will discuss why it is lagging or why it is leading. We have some phase sequences there, so that we will discuss in next class. Okay.
Is this answer correct, sir? I think IA answer is wrong, sir.
Then how much? That's why I'm asking. Is this correct?
No,
This
sir, I
minus
didn't
75
calculate the exact value, but theoretically I'm saying, sir. Like if IAB is minus 45 degrees, then how IA will be minus 75 degrees, sir? Because line current will lead by 30 degrees, no, sir.
So that's why I'm saying, no. So we have phase sequence is there, right? So when you're drawing the diagrams, I will tell you now only. Right. See, if we assume that this is rotating in this direction, okay, these vectors are rotating in this direction. So this is VA, so this is VB, and this is VC, right? So with respect to this, so this VB is leading or lagging? Is it leading or lagging here?
Lagging, sir.
This VB is lagging, right? If you assume that this is the direction of rotation in this case,
Leading.
so leading, right? So that means sometimes what will happen, you may get that plus 30 degrees lead here in case of line voltages. So with the same thing, so you may get minus 30 degrees lag or plus 30 degrees lagging here. Okay. So that is known as phase sequence. We are supposed to discuss in the next class. It is known as phase sequence. We have R phase, Y phase, B phase. Suppose if R phase is there, B phase comes in between, and you have Y phase. Right. So in this case, so it is like this. So depending on how the phases are rotating, so based on that, this phase sequence will change. So we'll discuss in detail in the next class. So any questions here?